Hello students. So today in this lecture, we are going to see the Fourier series that where we have to use the Fourier series formulas and uh, what type of useful integrals we will learn. It will help you to solve the Fourier series questions. So in Fourier series, when we have to find this series, so we have given a function fx which is periodic in nature. Okay. So what is periodic function? Periodic functions are like sine x function, which is periodic after 2 pi interval. It means that after a certain interval, the function repeats its value. Okay. So that we call as a periodic. So when we have to calculate the Fourier series, there are values of x on which function is dependent. So there are two types of x values. First is x values which is belongs to n pi, and another one is the x value which is belongs to whole number. So when x belongs to n pi, if a question is like we have given a limit of x from 0 to 2 pi. So here we can see the limit is from x is in the range of pi. So we have given a function of fx which is defined over c to c plus 2 pi. So here as you can see the overall interval is of 2 pi. So we can see that the period for that interval is 2 pi. So for that we will use the formula of fx which is a naught by 2 summation of n is equal to 1 to infinity a n cos n x plus b n sin. We have to use that formula to find the series for the function n. Okay. So in this question, the limit can be given in two ways, like 0 to 2 pi interval and the interval of minus pi to 2. Okay. So we have to remember these limits. So as you can see in the formula, there are three constants a naught, a n, and b n. So firstly, we have to find these three constants so that we can create our Fourier series. So for that, we have a formula. For a naught, we have the formula like 1 upon pi integral over the limit we have given and fx here. There the function is. Same for the a n, we have the formula 1 upon pi integral over the limit we have given and the function fx over which the limits are defined, and here extra term cos nx and we have to integrate. Okay. So same for the bn, we have the same formula similar to an, but instead of cos nx we have sin nx. So now this is the formula for when x belongs to n. Now what we see that if the x belongs to whole number, what does that mean? Like we have given a function fx which is defined over the interval of c to c plus 2l. Okay. So here as you can see the overall periodic for that interval is 2. It means after every 2l interval it will repeat this value. So in question the limit is given in the in two forms like from 0 to 2l or minus l to l. So, okay, for 0 to 2l like 0 to 4, 0 to 2 and something like that. Okay. And for minus l to l like minus 2 to 2, minus 4 to 4, something like that. So whenever we have seen the question and when we see that the value of x in the form of whole number, then what we use the formula as fx is equal to a naught by 2 plus summation over n is equal to 1 to infinite a n and cos n pi x by l. Here the extra term pi by l is included. Okay. And same for bn sin n pi x by l. So you have to remember one formula and remember whenever we shift the whole number, then instead of cos nx, we will use cos n pi x by l. Okay. And for sin nx, we will use sin n pi x. So similar, what the thing is that we have here given the value of s in the form of 5, but here in the form of n. So we have to find what is the value of n from the. For that again we have a formula. For L, we have what we have to do. We have to take the differences of the limit. So L is equal to upper limit minus lower limit and divided by 2. So that way you can get the limit of the function. So example, let's take for the 0 to 4. If we have to find the L value for that, simply upper limit is about 4 your limit is b. That is why we can get the value of n. Okay. So again, now for that we have a formula to find the values of a naught, an, and bn. We require to get the ct. So for a naught, the formula is 1 upon L. In the previous one, we have the formula for 1 upon 5. So here we have a formula 1 upon n. And integration over the limit, we have given fx. Okay. Now for the same for the an, the same 1 upon L integral over the limit fx. Now here we have to use cos n by xy. Okay. Now same for the bn, we will use sine n by xy. It is similar to that instead of the sine angle difference. Their angle is nx when x belongs to phi, and if x doesn't belong to phi, then we have to use n by xy. I think it is clear now. So now we will see some useful integrals which will help you to solve the question. So some useful integrals for the we have a sine n phi. So whenever when we are solving the question, then maybe many times we have got the output of integral as sine n. So whenever the sine n phi is came, then you have to directly replace it with 2. And here n value belongs to 0, 1, 2, and so on. Similar, we have the formula for cos n phi. If you are after the integral, you will get the value as cos n phi. You can directly replace it with minus 1 power. But here you can do one thing. If n is even, then you can simply put this value as 1. And for n is odd, then we can simply put the value as minus 1. Okay. Now also we have the formula for half angle, where like sine n pi by 2. It means like sine 3 pi by 2, sine 5 pi by 2, something. Okay. So for that, what we have to do, whenever we have given a n in the form of even, then the value can directly replace with 0. Whenever the value of n is in the form of 159, then we can increase the value by 1. And same for 377, we can directly replace by minus. Okay. Same for the cos n pi by 2. Whenever n is odd, we have to directly replace cos n pi by 2 by 0. Okay. Whenever n is the multiple of 4, then you can directly replace it by 1. And whenever n is the multiply of 2n plus 2, then you have to directly replace it by 2. Okay. So now let's see some integral formula. Okay. So if we do have integration of sine nx dx over a limit of the interval difference is 2 pi, like 0 to 2 pi or minus pi to pi. So if these are the limits and you have to integral the sine nx over it, then you can directly replace the integral by 0. Because after solving this integral, you will get the answer 0. So instead of solving it, you can directly replace. Same for the cos nx integral, you can directly replace it with 0 if the limits are of difference 2 pi. So now the next important formula is partial integration. So whenever you have a function of u and v which is dependent on x, so when we have to integral of the product of these functions, then how we have to do? We have to just simply put the function first u as it is, then we have to do the integration of second function v dx, and then we have to subtract, and then again we have to integrate. But before integration, we have to do the differentiation of first function, which is u, and the integration of second function, which we have calculated in that part, same, and we have to multiply that. Okay, and then whatever result we will get, we have to multiply. We have to integrate over it with the dx. Okay. Then after that, overall, whatever we have got the result, we have to just put the limit over it, whatever limit we have like a. So now another two main formulas are like if you have a integral where the first function is like e power ax, or something, and second function is in the form of sine or cos. Then you have to directly use this formula, this simple formula. Just what you have to do, we have to directly put e power ax as it is and divide it by a square plus b square. Either it is for the sine px or cos px. You have to use this thing. Now, then what we have to do, we have to multiply it by a sine px. If we are doing the integration with respect to sine px, then we have to write a sine px. And if we are doing the integration with cos px, we have to directly put a cos. Okay. Then for sine, you have to do the minus sine b cos px. And when we are doing for cos px, we have to use plus b sine. Remember this thing when we use the negative sign and when we use the positive. And other whole things are same for both of the cases. Whenever sin px term is from, you have to use minus sign, and whenever cos px is from, you have to use plus. Now next you will see sometimes we have given a graph, like we have a graph, and we have what we have to find, we have to find the equation of line. Okay, and we have to find the Fourier series for. Okay, so let's this is our x0 comma y0, our equation. At that position we have a for x1 and y1. So for that we have to calculate first the equation of line, which is our like our fx, or we can say y, or this is our x. So for that what we have to do, we have to first find the equation of line, then we can calculate the Fourier series for that y, or we can say f. So what is the formula? Formula is equation of line y minus y0 is equal to mx minus. So here the m is our slope. So how to calculate the slope? We'll calculate the slope by y1 minus y0 divided by x1 minus. So when we got the value of slope, we directly put it into our main equation 1, and then you have to choose any point as x0 and y0, like this is our x0 and y0. Simply just put the value and get the equation is the form of y is equal to mx plus b. So this will be your equation. For that you have to calculate the Fourier. Okay, so I hope you all understand, and you also learn how these simple useful integrals help you to solve some numericals. So now in the next video you will see some numericals on Fourier series. Thank you so much.